Have you ever wondered how airplanes, colossal metal birds, seemingly defy gravity to soar high in the sky? This marvel of engineering is made possible by the magic of aerodynamics, a science that studies the motion of air and how it interacts with solid objects, like an airplane. Imagine an airplane moving forward, cutting through the air. Its wings create two types of airflow, laminar and turbulent. Picture the laminar flow as a calm, orderly river gently streaming over the upper surface of the wings, while the turbulent flow resembles a wild, chaotic rapids underneath the wings. This contrast in airflow creates a pressure difference, the first step in creating lift. Now let's dive into the world of Bernoulli's principle. As the air velocity increases, the air pressure decreases. This principle is at play on the airplane's wings. The faster airflow over the curved upper surface of the wing creates a low-pressure area, while the slower airflow underneath forms a high-pressure area. This pressure difference is what generates lift, the force that keeps the airplane airborne. The angle of attack, the angle between the wing's chord line and the direction of the oncoming air, plays a crucial role in controlling this lift. By adjusting this angle, pilots can manipulate the amount of lift produced by the wings. Airplane wings aren't just any shape. They're designed as an airfoil, a specific shape optimized to generate lift efficiently at various speeds and angles of attack. Think of an airplane wing as a finely tailored suit, customized to the wearer's body for maximum comfort and efficiency. The magic of aerodynamics is what makes it possible for us to take to the skies, connecting us to every corner of the world. But flight isn't just about lift. Propulsion is the engine that drives an airplane forward through the sky. Now let's talk about the heartbeat of an airplane, the jet engine. It's a marvel of modern engineering, compressing incoming air, mixing it with fuel, and igniting the mixture. The hot exhaust gases then get expelled with great force through a nozzle at the engine's rear. This process is a practical application of Newton's third law of motion. For every action, there's an equal and opposite reaction. The force of the gases shooting backward generates a forward thrust that propels the airplane through the air. But here's the catch. To overcome drag and keep moving forward, the thrust generated by the engines must exceed the total weight of the airplane. This is known as the thrust-to-weight ratio. Pilots control this by adjusting the engine power, influencing both speed and altitude. In a nutshell, a jet engine breathes in air, ignites it with fuel, and exhales it with enough force to propel the airplane forward. Now that we know how airplanes fly and move forward, how do they steer and navigate through the sky? Let's talk about control systems. They're the tools pilots use to maneuver these giant birds in the sky. First up, ailerons. These are located on the trailing edge of the wings, and they move up and down asymmetrically. This controls the roll, or the tilting motion, around the airplane's longitudinal axis. Next, we have the elevators. These are stationed on the horizontal stabilizer at the tail of the airplane. They move up and down together to control the pitch, or the nose-up or nose-down motion around the lateral axis. Lastly, there's the rudder. This is mounted on the vertical stabilizer and moves left and right to control yaw, or side-to-side motion, around the vertical axis. Pilots manipulate these control surfaces using the control yoke or stick in the cockpit. They adjust them to maintain stability and steer the airplane as desired. So it's the ailerons, elevators, and rudder that give pilots the reins to ride the sky. Beyond the obvious, there are several lesser-known facts that contribute to the miracle of flight. Let's delve into those. Have you ever noticed how airplane wings flex during flight? This isn't by accident. Wing flex helps distribute aerodynamic forces evenly, reducing structural stress and enhancing flight efficiency. Now, imagine you're a pilot, controlling a massive airplane with just the flick of your wrist. This magic is made possible by fly-by-wire technology. Instead of traditional mechanical linkages, electronic systems interpret your commands and transmit them to control surfaces via wires. This technology allows for more precise control and even automation, making your flight safer and smoother. But what about the airplane's center of gravity? This must be meticulously managed to ensure stability and control. A shift in cargo or passengers can tilt this delicate balance, requiring pilots to adjust trim settings accordingly. Even the unseen aspects of an airplane, like wing flex and center of gravity, play crucial roles in ensuring a safe and smooth flight.